Welcome students. Before going to see in detail how the order of reaction is determined by using the half-life method, I would like to explain you regarding the timetable of your exam. Here see the B.Sc. CBCS pattern part 1 semester 2 exam March April 2021. Your exam it will going to start on 9th August 2021. Now 9 August 21 it is the English paper and the subject code for English paper it is 72,840 and the time of your exam it will be from 2:30 p.m. to 3:30 p.m. and the nature of question paper here it will be MCQ type. You have to select the most correct alternative from given options. Okay, and you have 2 marks for each question and you have to attempt total 25 questions. On 10th August, you have to attempt the physics paper 3 and its subject code 72,843. Physics 4 paper on 11th August, same time at 2:30 p.m. to 3:30 p.m. and on 12 August, remember, on 12 August at timing 2:30 p.m. to 3:30 p.m. you have to attempt the chemistry paper number 3 physical chemistry and remember the nature of the exam it will be MCQ type. You have to attempt in all 25 questions and each question has 2 marks. So prepare well. And the second chapter that is the chemical equilibrium. Here the second chapter chemical equilibrium it is not included for your syllabus. Okay, I repeat once again the second chapter chemical equilibrium it is not included or it is deleted from the point of exam, but you should gain knowledge regarding the chemical equilibrium. If there will be enough time, at that time I will taught you the second chapter chemical equilibrium. Time being, prepare well all the MCQ questions on first chapter that is the chemical energetics. Then second chapter it is deleted, it is not meant for your exam. Third chapter theory of kinetic theory of gases and the last chapter that is chemical kinetics. For this exam you have to prepare only 3 topics, 3 units. First unit chemical energetics, second unit chemical equilibria. It is deleted, it is not for your exam. And third topic kinetic theory of gases and fourth topic chemical kinetics. So prepare well the chemistry paper 3. It will be on 12 August 2021 at 2:30 p.m. to 3:30 p.m. and the nature of exam, it will be MCQ type. You have to attempt total 25 questions and each question has 2 marks. Remember, the question paper code, that is the subject code of chemistry paper 3 and 4, it is the 72,844. Remember well. And then we begin with the next point, that is the determination of order of reaction by the half-life method. You know, the first order reaction, it is independent on the concentration. That means in case of first order reaction, the half-life time, it is independent on initial concentration. In case of second order reaction, half-life time, it is inversely proportional to the initial concentration. Okay, and in case of third order reaction, half-life time, it is inversely proportional to square of the initial concentration. That means in general we can say that the half-life time, that is T1 half, it is proportional to 1 by A raised to n minus 1, where n is the order of reaction. And if A1 and A2 are the initial concentrations of the reactants at half-life time T1, T half T1 and T half 2. That means time T1 and T2 respectively. Then from this equation we can say that time T1 half 1, that is time 1, it is proportional to 1 by A1 raised to n minus 1, because we have considered A1, it is the initial concentration at time T1, and at time T2 we have considered the initial concentration as A2. Therefore we can say that the time T2, it is proportional to 1 upon A2 raised to n minus 1, where n is the order of reaction. And dividing this equation number 1, dividing this equation by this equation, we can write T1 by T2, it is equal to A2 raised to n minus 1 upon A1 raised to n minus 1. Or we can say that here T1 by T2, it is equal to A2 by A1 raised to n minus 1. Then taking log on both sides, here we can write log of T1 by T2, it is equal to log of A2 by A1 raised to n minus 1. Okay, and A2 raised to n minus 1. Therefore, this numerator's power and denominator's power, we have n minus 1, same power. Therefore, we can say that n minus, it is equal to n minus 1 into log A2 by A1. Therefore, n minus 1, it is equal to log of time 1 minus time 2, log of time 2 divided by log of A2 minus A1, and n, it is equal to this minus 1 we can transfer to the right hand side, and hence we have n, it is equal to 1 plus log of T1 minus log of T2 divided by log of A2 minus A1. And by plotting the graph of X versus T for different initial concentrations of A1 and A2, the half-life time can be determined by dividing the initial concentrations A1 and A2 by 2. Therefore, if we plot the graph of, here we have the concentrations x1, that is A1 by 2, decrease in concentration, and here x2, that is A2 by 2, versus time t half for first time and t half of second time. And here the nature of the graph here like this. Okay, and by using this formula, n, it is equal to 1 plus log of time 1 minus log of time 2 divided by log of A2 minus A1. We can find the order of the reaction. That is, we determine the order of reaction by using half-life time method. Okay. Then the graphical method you have already studied. Then the differential method, here you have also studied. Okay, and if we take the log of dx by dt at one time divided by dx by dt at second, it is equal to log of concentration C1 raised to C2, C1 by C2 raised to n. Therefore, log dx by dt minus log of dx by d2 at second time, it is equal to n into log C1 minus C2. Therefore, n it is equal to this, and by using this method we can find the order of reaction. So prepare well. And then the next point, that is the Arrhenius equation. You know, the effect of temperature on the rate of reaction. All of you know, if we increase the temperature of the reaction, a rate of the reaction, it increases. All of you know this, and it is first studied by the scientist Arrhenius in 1890. You know, and it is our common observation that the higher temperature speeds up the reactions, or as we increase the temperature, rate of reaction increases, and it may be doubled when we increase the temperature by 10 degree. Okay, and the reason for this were not clear, and in 1899 the Swedish chemist Arrhenius combined the concept of activation energy and Boltzmann distribution law to one of the most important relationship in physical chemistry, and that important relationship in the physical chemistry, it is the Arrhenius equation, you know, and the Arrhenius equation, it is given by K, it is equal to A into E raised to EA divided by RT, where K, it is the velocity constant, A, it is the Arrhenius constant, EA, it is the activation energy, R, it is the gas constant, and T, it is the temperature. Okay, T, it is the temperature, and here E means exponential form. Okay, so the exponential form of this equation, it can be interpreted with the help of graph, and taking logarithm of both sides, we can write here ln k, ln, that is natural log to the base e, ln k, it is equal to ln a into e raised to minus ea by rt, it is equal to ln a plus ln e raised to minus ea by rt, and it is equal to minus ea by r into 1 by t plus ln a. And if we equate this equation with the equation of straight line, then we can write ln k, it is equal to ln A minus EA by RT. And here EA, it is the activation energy, and activation energy, it is the certain minimum energy which is required to pass the barrier in between the energy of reactants and products. And each and every reactant, it must have a minimum energy. Okay, then they will get converted into the product. Okay, this is the activation energy. Okay, so we will see the reaction rate theory to the next lecture, and I mean that is the last point of this chapter. So prepare well the Arrhenius equation.